Hello students, welcome to the session on uh, Mechatronics. In this session we will be discussing about the previous year question which was in 2015 scheme. And you have to understand that the syllabus content in 2015 scheme and 2019 scheme for KTU Mechatronics in mechanical engineering is same, only the module wise distribution is different. So in this session we will be discussing about the previous year question, and let's move on to the session. So module 1 the topics is mainly regarding the structure of mechatronic system and the different types of sensors. And at last of the module 1 you will be dealing with some types of actuators. So in this session we will be dealing mainly with the questions related to sensors. The first question is explain the working principle of thermocouples. The marks for this question was 2 marks. So in this possible mark distribution for the principles, if you're writing about the principle of the thermocouple, you will be getting 2 marks. So the important points which you have to mention here is the Seebeck effect of the thermocouple, and you have to mention the hot junction and the cold junction. And you can supplement your answer with a diagram. It is mentioned here. So you have two metals, different metals A and B, which is connected and dipped in two junction. One is hot junction, the other is cold junction. And due to this temperature difference, an EMF is produced. So with respect to this EMF, you can understand the temperature of the particular hot junction, and you have one reference junction which is taken as the cold junction. Now the next question, what is thermospile? What is the principle used to increase the sensitivity of thermopile? It is in this question you have to understand it is actually a thermopile, and the marks for this question is 4 marks. So the possible marks distribution for this question is thermopile. Explaining about the thermopile you will be having 2 marks, and the principle of sensitivity is 2 marks. So the important points you have to mention in this answer is, first one is thermopile means you are connecting the series of thermocouples. Okay, and the principle to increase the sensitivity is the voltage is generated from the temperature difference between two dissimilar metals, as I told in the previous question. So if you are connecting these dissimilar metals in series, you will get a greater EMF which increases the sensitivity, and you can supplement your answer with a diagram which is shown here. You are having two dissimilar metals, one is copper wire and the other is one is iron wire, and you have two different junctions, and you are connecting at the end by using a series of copper and iron wire, and you are getting an output voltage which increases the sensitivity of the thermopile. Now the next question is explain the working of an anyone contact temperature measurement system, non-contact temperature measurement system. The question is any one type. So the possible marks distribution for this question is the total marks is 4 marks. In this diagram carries 1 marks, the principle of working carries 1 marks, and the working carries 2 marks. So the important points to be mentioned in your answer is any one non-contact temperature measurement system. So you can mention the first one is it is a pyrometer. The pyrometer can be total radiation pyrometer, infrared pyrometer, or an optical pyrometer. Okay, and the diagram for each one is shown here. The first one is total radiation pyrometer here. So in total radiation pyrometer, you can see all the radiations is incident on a mirror, and it is reflected back toward the focal point into a thermocouple or thermopile in order to get the temperature. Okay, and the second one is infrared pyrometer. So in infrared pyrometer, you can see a protective window which allows the infrared rays to get into between, and you have a photovoltaic cell which gives the voltage or EMF with respect to the temperature. Okay, and the third one is optical pyrometer. In optical pyrometer, you can see a filament here. Okay, and you have the temperature, the temperature from the object, the radiation is incident onto this particular filament, and from here you can understand that if the object is at a higher temperature than this particular filament, then the filament will be visible like this, like the first figure. And if the object and filament is having same temperature, the filament will not be visible in this particular circle. And if the object is having a less temperature than filament, you can have a dark background here. So with this you can understand the temperature. So there are so the question is any one contact non-contact temperature measurement system. So you can mention any one. You can draw the diagram, principle, mention the principle, and you can mention the working. Now the next question, illustrate the working of a strain gauge load cell. Okay, so the question marks for this question is 8 marks. Okay, and the diagram carries 3 marks, the principle carries 2 marks, and the working carries 3 marks. So you can see here, actually the strain gauge is an force measuring transducer, and the working principle is that it uses the electrical resistance, and when a force is applied, due to this force the resistance of the element changes, and which measure the strain. And you can additionally mention the use of an V-stone bridge to measure the strain. And this is the diagram which we can mention here. Additionally, if you mention the diagram of a Wheatstone bridge, it will be an added advantage while answering this question. Now the next question is list 4 examples of temperature sensors. The question carries 2 marks, and the question is list only. You don't need to explain the working. So each example carries 0.5 marks. So 0.5 into 4, which carries 2 marks. So you can mention about the examples are bimetallic strip, thermistors, thermodiodes, thermocouples. You can mention non-contact temperature sensors also. Anyone you can mention. And if you can draw the diagram, it will be an added advantage, but it is not necessary because the question is only for 2 marks. Now the next one is compare the working of resolver and synchro. The question carries 6 marks. So for each one, like resolver and synchro, each diagram carries 1 mark and the explanation carries 2 marks. And you can mention the important points that has to be mentioned in this answer is, if you are taking the synchro, you need to mention that there is 3 stator windings and 1 rotor winding, and this stator winding is 120-degree apart. And if the shaft is rotating with this particular rotor, and the voltage developed in each coil. So you know this each coil is 120-degree apart, and the rotor is rotating at a particular angle theta with respect to the stator winding. So you can see that the voltage developed from S1 to S3, this part is V sin omega t sin theta, and S3 to S2 will be V sin omega t sin theta plus 120, and S2 to S1 will be V sin omega t sin theta plus 240. So these are the main points you have to mention regarding synchro. And if you are taking resolver, you need to mention that there are 2 stator windings and 2 rotor windings, or 2 stator and 2 rotor winding, which are kept at 90-degree apart. And you have to mention about the voltage developed in sine and cos windings. So the tan theta, the angle of rotation will be, tan theta will be is equal to the ratio of the voltage developed in sine windings and the cos windings. Now the next question is, suggest 2 applications of Hall effect sensor in a mechatronic system. So the question is suggest 2 application. You need to mention 2 application. The question carries 2 marks. If you are mentioning 2 application, you will get 2 marks. And you can see here the first one is wheel speed detection, motion sensing, sensing the rate of flow, liquid leveling tank. For measuring these things, you can use the Hall effect sensor. And just for this question, the diagram is not necessary, and you have to understand that this is the diagram for an Hall effect. That means when a current carrying charges are passing through a magnetic field, there will be a small deflection here. So the negatively charged electrons will come to one part. So that means the negative charge will be accumulated in one part. So comparatively, the other part will be positively charged. So this is which is called an Hall effect. The same effect is used for these particular purposes which is mentioned here. So for this question, you have to mention only 2 application. Each carries 1 mark, and you will get 2 marks for this one. Now the next question is, describe the term hysteresis error and non-linearity error. So this is related to static characteristics of a sensor. Okay, so for each spec you will get 1 mark. So the first one is hysteresis, and you can see the hysteresis is the continuously increasing change or a continuously decreasing change. You can see this one in this graph. In this graph you can see the increasing nature and the decreasing nature is different. So in between this there is a small difference, and this difference is called hysteresis error. Okay, and the non-linearity is actually it is the maximum difference from the straight line. You can see if you have an two endpoints, if you wish to draw a straight line in between, but in the actual process it will be a curve. So the difference between the curve and the actual this actual curve and this particular straight line, which is called the error. Okay, so this question carries only 2 marks, so no need to mention this one. If you are supplementing this question with these graphs, it will be an added advantage and it will fetch you the full marks for this particular question. Now the next one is differentiate between absolute and incremental encoders, and this question carries 2 marks, so each encoder will be carrying 1 mark. And in this for this particular 2 marks question, you have to mention only two things. For incremental encoder, you have to mention that it detects the changes in rotation from datum position. So there is some datum position for this particular encoder. So you can see this is then incremental encoder with a series of slots, and there will be home slot which is near to the center. Okay, so that is called a datum position, and with respect to that, how much this wheel has rotated, that is mentioned in incremental encoder, and the resolution is given by 360 degree divided by number of slots on the disk. So that is 360 degree divided by n. Okay, and in absolute encoder, it gives the actual angular position. And you can see this is an example of an absolute encoder. You can understand the actual angular position of the shaft, and there are two types of codes which is used. One is binary code and gray code, and the resolution is given by 360 degree divided by 2 raised to n, where n is the number of bits. So if n is 3, you can see 3 bits here. That means 3 slots will be there. Likewise, 3 LEDs will be there for to get the pulses, and the number of sectors will be is equal to 2 raised to n. So if it is 3 slots, so it will be 2 cube, which will be 8. You can count here 1 2 3 4 5 6 7 and 8. So this is a 2 marks question, so you need to mention only these points. If you are supplementing diagram for this question, it will be an added advantage. And next question, though the encoder wheel layout of an gray coded absolute encoder with 45 degree resolution. This question carries 3 marks. The resolution of the track is 1 mark, and the layout is 2 marks. So you can see here, resolution is 360 degree divided by 2 raised to n. So the resolution is 45 degree, which will be equal to 360 degree divided by 2 raised to n. You will get n is equal to 3. So that is the number of tracks, and sectors will be equal to 2 cube will be equal to 8. So you can make a 3-bit encoder as n equal to 3. You can, from decimal to binary you have first conversion, and from binary to gray code you have another conversion. From binary to gray code you have a conversion using a XOR logic exclusively or logic. Okay. Now the next question, explain the working of incremental and absolute optical rotary encoder. Why gray code is used in coding absolute encoder? This is a question came in December 2019, and the marks for this question is 10 marks. So the possible marks distribution for this question is, each encoder carries 4 marks, the diagram carries 1 mark, the light pulses and rotation significance, which is 1 mark, the resolution carries 1 mark, working and rotation will give you which 1 mark, and finally if you are explaining about the gray code, that carries 2 marks. Okay, so the important points to be mentioned in this answer is, in incremental, as I told before, it detects changes in rotation from the datum position. The resolution is given by 360 degree divided by number of slots. You can mention the datum position slot, and you can also understand whether the rotation is clockwise or counterclockwise. To know whether the rotation is counterclockwise or clockwise, you have to have three slots here. The first one is, I will just mention here. So you can have a, datum slot here, and you have to have a middle track here like this parallelly with respect to this outer track, and the width of this slot is same as the outer track, and the middle track is placed such a way that the half portion of the slot will be like this. The end of the middle track, the half will be at the middle of the outer track. So like this, like that, the slot will be arranged, and now the pulses, you will be having one more, the three LEDs here, and it will be giving the signal. The inner will be giving the datum position, which is for this one. Okay, and this will give the pulses, this will give the number of rotations, how many. So if a pulse come from this LED, that means that is one rotation is completed. Now you have the other two LEDs here. This is for the outer track, and this is for the middle track. And now take a condition that if pulse come, firstly you can take the rotation as clockwise. So first pulse come from this slot, and the second pulse from this slot, now third from this slot, and the fourth from this slot. So you can understand that outer middle, if the series is like this, now this is counter clockwise, and for the counterclockwise, the first pulse will be from the middle slot, then outer slot, middle slot, outer slot. So if that series is coming, then we can understand that it is counterclockwise. So I repeat, if the signal comes from outer middle, then it is, in this case, in this particular example, that will be clockwise, and if it is middle outer, and that is counterclockwise. Now coming to absolute encoder. If you are taking this absolute encoder, as I mentioned, it gives the actual angular position of the shaft, and the resolution is 360 degree divided by 2 raised to n, and the gray code, and you have a decimal, and it is converted into normal binary, and finally it is converted into into a gray code using XOR logic. Okay, so it is XOR logic. It is also called exclusively OR logic. And why gray code we are using? The gray code we are using to avoid the fractional bit change. So these are the important points which has to be mentioned in this question, and you have to supplement your answer with this diagram. It is a must, and you will, if you are diagramming and explaining these points, you will be getting full marks. Now the next one is describe the working of an LVDT with a neat sketch. It is linearly variable differential transformer, and the marks for this question is 6 marks. The possible mark distribution is diagram is 2 marks, principle is 2 marks, working and voltage variation is 2 marks. So the important points to be mentioned here is this LVDT is carrying two coils, one primary coil and one secondary coil, and this secondary coil itself is divided into two parts. One is secondary 2 and the other one is secondary 1, which is opposite in phase. Which is opposite in phase means the voltage developed in secondary 2 is in opposite phase with respect to the voltage developed in secondary 1. The principle of working of an LVDT is mutual induction. Likewise, if you are giving a constant AC supply to this primary coil, and this will create an magnetic field, and you are inserting an ferrous rod into this particular system. So what happens is that the magnetic field is distorted using this ferrous rod, which induces an voltage, and that output voltage is taken from this secondary coil. Okay, and the EMF general equation is given by E is equal to m into di by dt, where m is the mutual inductance, and the voltage variation, you have to mention the voltage variation in secondary coils 1 and 2. Like this, just I will explain here. If we are inserting this particular ferrous rod here, so if this position is initially here in this particular part, if the ferrous part is at secondary 2, what happens is that the voltage from the secondary 2 will be at the maximum. So when we are just inserting, the maximum voltage will be here. Okay. Now, as I told before, if you are inserting ferrous rod again inside this particular tube, what happens is that the voltage will be developed in secondary one also, but that is opposite in phase. So that means the voltage developed in secondary one will cancel out the output voltage developed by secondary 2. So while we are inserting this ferrous rod, what happens is that the voltage will gradually reduce like this, and if the ferrous rod is at the middle, what happens is that the voltage developed by secondary 1 will be is equal to secondary 2, and the voltage is opposite in phase, so the output will be is equal to 0. Okay. And again, if you are inserting into secondary 1, what happens is that the voltage developed in secondary 1 will be more than secondary 2, but secondary 2 will be opposing secondary 1 as it is in opposite in phase. So gradually what will happen at the end of secondary 1, the voltage will be maximum. So this is the voltage variation of an LVDT, and this is a phase diagram which shows that secondary 2 is opposite to the secondary 1 in voltage. Okay. So you have to mention all these points, and you have to draw this diagram. You have to mention this voltage variation also, then you will be getting 6 marks for this particular question. Now the next one is explain the working of any one type each of flow and pressure sensor. You have to look into the question, you have to mention, you have to explain the working of any one type. So the marks for this particular question is 4 marks, and you can mention any one type of flow and pressure sensor. You have to mention for each sensor, you have to draw the diagram, you have to mention the working principle, and you have to mention the working. Only this is required. So I'm mentioning here two types of sensors. One is flow sensor. Example I am mentioning here is orifice plate. Second one is turbometer. And in pressure sensors, you can here I am mentioning about the fluid pressure sensor. You can use diaphragm or you can use bellows. In diaphragm method, you are using a strain gauge on top of the diaphragm to measure the pressure. So these are the diagrams. So this is an orifice plate which you might have studied in your fluid mechanics, and you have conducted experiment in your fluid mechanics lab itself. So this will be quite easy for you to draw and mention the principles, that principle and the working. You can mention the equation also, or else you can go for the turbometer. Turbometer is very simple. If the flow is happening through this particular pipe, and if you are inserting a turbine meter here with a multi-blade rotor, what happens is that with respect to the flow rate, the angular velocity of this particular turbine will vary. So if you have a high velocity flow, then the angular velocity will be more for this particular turbine rotor. So with respect to that, we have a magnetic pickup coil which gives the EMF with respect to the rotation of this particular turbine meter. Okay. Now for the pressure, there is a diaphragm and bellows. You can see this is the diaphragm. The fluid will be entering from this particular port, so it will be hitting this particular diaphragm. So there will be movement on this particular diaphragm, which will be measured using a strain gauge. Okay. Next one is bellows. So there in this through this particular opening, the fluid will be allowed to get inside. So with respect to pressure, what happens is that this particular serrations will get expanded. So such that with respect to pressure, you can understand that how many pressure is exerted or how much pressure is exerted into this particular bellows. Now we will go with the next question. Suggest a method of sensing temperature using non-contact method. Explain the method with suitable texture. So this question is asked in March 2020. This is a repeat question. So suggest a method, only one method you have to mention. So this question we have discussed before. So this question is for 4 marks. The diagram carries 1 mark, principle carries 1 marks, and the working carries 2 marks. You can mention any one of the pyrometer, sketch it, write the principle, write the working, you will carries 4 mark. Distinguish between features and features of synchro and resolve. This is also an repeat question. This question carries 4 marks. Each diagram 1 mark and explanation 1 mark. You have to remember about in synchros there is 3 stator and 1 rotor, and reservoir you have 2 stator coil and 2 rotor coil, and you have to mention about the voltage in sine and cos windings. Now next question, describe the working of piezoelectric vibration sensor. Okay, the question carries 6 marks, the diagram carries 2 marks, principle 2 marks, and working carries 2 marks. The principle is very simple. When stretched or compressed on a piezoelectric crystal, it will generate electric charges. So that is the working principle of an piezoelectric vibration sensor. You can mention that it is a piezoelectric element or crystal is used in piezoelectric vibration sensor, and the peculiarity of this particular piezoelectric crystal is such that if you are stretching or compressing, it will generate a small EMF. Okay, and it is with respect to the charge sensitivity, you will get more EMF with respect to the charge density, and there is one equation which is called Q is equal to Kx is equal to SF, which if you remember you can mention it, otherwise it is not a mandatory item here, and that is the principle. Now this is the diagram. In this diagram you can see there is a piezoelectric element in between these two plates. Okay, and there is a solid base here, and you have a seismic mass here means it is a vibrating load, and during vibration what happens is that the piezoelectric element will be stretched or compressed. Likewise you will get an output from this particular as an EMF, and this is the working of an piezoelectric vibration sensor. Now the next one is describe the working principle and applications of acoustic emission sensor system. This is a new question which is asked in March 2020, and the diagram carries 1 mark, principle carries 1 mark, and the working carries 2 marks. Okay, so in this the important point you have to mention is that in the acoustic emission, it is a phenomenon of sound and ultrasound wave radiation in materials which undergo deformation and fracture process. I will mention this with an diagram. So you know that you might have seen the tankers, steel tanks like gas tanker and diesel tanker which is moving on through the roads. Okay, so that is actually manufactured using MS sheet or stainless sheet. Okay, which is rolled on to make into an like an hardly into an elliptical shape or onto an circular shape. So during this particular fabrication process, the tanks will be tested using a pressure test. Okay, so during pressure test what happens is that we will be testing the tank using a pressure, it will be almost double the time of the pressure rating. For example, if the tank is manufactured for 3 bar capacity, it will be almost tested with 4.5 bar or 6 bar, etc. So what happens is that when we are measuring this one, if during this fabrication process there is a chance of getting a micro crack inside the material of this particular tank. So when we are checking this particular pressure test using an acoustic emission sensor, what happens is you can sense the acoustic emissions from this micro crack, and you can suspend the pressurization test. Whereas if there is no acoustic emission sensor, you cannot judge whether there is a micro crack, and further it will lead to the leakage of contents of the tank and failure of the tank. Okay, so this acoustic emission monitoring is a non-destructive testing, and you can refer into the history of that one. It was used first time in nuclear reactor components. Now, next question, define the following sensor characteristics: time constant and hysteresis. This question is for 4 marks, each carries 2 marks. So hysteresis, I have explained it before in a previous question. So this is a repeat question. So output vary according to the quantity being measured has been reached by continuously increasing change or continuously decreasing change. So you can mention this with this particular graph. Increasing and decreasing is having different paths, and this is particularly which is mentioned as the error. And time constant, it is a measure of inertia of the sensor, which is particularly 63.2% of the response time. This is the particular graph you have to mention, and this time constant is a dynamic characteristics, and hysteresis is a static characteristics. So you explain this point with the graph, explain this point with the graph, you will get 4 marks. Now the next one is explain the principle of Hall effect, how a proximity sensor works on the basis of Hall effect. This is a repeat question. Hall effect sensor, the principle is 2 marks, explanation of the sensor is 2 marks. You can mention the principle of Hall effect using this particular diagram, and the working of this particular sensor, it is used to detect the proximity, presence or absence of a magnetic object using a critical distance. So you can see here when the magnet reaches this Hall effect sensor, it is giving an yellow light. So that means to a particular distance, preset critical distance, this will be measuring, and the object should be a magnetic object. So that is a point you have to mention here. So this carries uh, and the diagram carries 2 marks. So principle 2 marks, the working of the sensor 2 marks, and the diagram carries 2 marks. Now the next question is illustrate the working principle of incremental and absolute rotary encoder. This is a repeat question. So I explained this one before, how to write this question. So you have to mention about the slots, resolution, latent position slot, clockwise and counterclockwise rotation for the incremental, and for the absolute you have to give the relevance of the codes and the resolution and the number of sectors and the number of slots. Now the next question is explain with schematic diagram the working of synchros. This is also an repeat question. You have to mention the question is for 5 marks, diagram carries 2 marks, and the explanation carries 3 marks. In this one, I repeat, you have to mention the main point is 3 stator and 1 rotor. You have to mention this equation and for the development of the voltage in this coil. Okay. So now the next one is illustrate the principle of operation of turbine meter for the measurement of liquid flow. This is the question is for 5 marks. If you are mentioning the principle, it is 1 mark, diagram is 2 marks, and the explanation is 2 marks. I have already explained about this one. So the principle is fluid flow results in rotation of the rotor, the angular velocity being proportional to the flow rate. So if you are having a high flow rate, the turbine will be the rotor of this, the multi-blade rotor of this turbine will be rotating at a high angular velocity, which is picked up by the magnetic pickup coil, and you will be getting an EMF with respect to the angular velocity of this particular turbine. And the next question, some temperature control switches are operated by metallic strips, how they work. This is also in fact an repeat question, but in this one explanation is asked. The marks for this question is 5 marks. That means principle is carrying 1 mark, diagram is 2 marks, explanation is 2 marks. The principle of this particular sensor is that it is the expansivity of this particular bimetallic strip. Okay, expansivity you might have studied in mechanics of solids about regarding the coefficient of thermal expansion. Delta will is equal to L alpha delta T, where alpha is the coefficient of thermal expansion. So with respect to that, you can identify two materials. One is with high expansivity material, which is placed at the outer, and the second one is low expansivity material, which is placed at the inner part. Okay, and what happens is that when the temperature is when the current is given, the temperature increases, and what happens is that this will get expanded, and during expansion and at a preset temperature, what happens is that this soft iron will be getting detached from the small magnet. Okay, and when the temperature is less than the set temperature adjustment, what happens is that this will get again the curved nature. This particular high expansivity material and low expansivity material will be a curved like structure, and so that the soft iron will get attracted to this magnet, and it will have a joint, and the electricity is passed. So when the temperature increases greater than the set point, what happens is that this soft iron and the small magnet will get detached. So this is called working of an biometallic strips. And next one is explain any two characteristics of a sensor. The each carries 2.5 marks. So I have listed all the static characteristics here. You can mention any one, but I suggest you to mention any two which is having either a graph or a figure, such that it can help you to get 5 marks very easily. So better to select two characteristics which is having a figure or a graph. Now next one, illustrate the working of any two modes in an ultrasonic proximity sensor. Comment on the deadband of an ultrasonic proximity sensor. So the working of an ultrasonic proximity sensor, the question carries 7 marks. The principle is 1 mark. Diagram is 2 mark, explanation carries 2 marks, and the possibility and commenting on the deadband is 2 marks. So the principle, you might be knowing that ultrasonic proximity sensor, it is the with respect to the sound waves, ultrasonic sound waves, you are checking the proximity of an object near to this particular sensor. And this is of two modes. One is opposed mode, in that the emitter and receiver will be at two opposite positions, and when an object is coming in between, what happens is that the emitted waves will not reach the receiver. So you can understand that an object is there in the vicinity of this particular emitter and receiver, which senses the proximity. Now the second one is opposed mode. In second one is echo mode. In echo mode, you can see the emitter and receiver is at same place itself, and the emitter will be emitting the signal, and when an object is there, what happens is that this will be reflected back to the receiver, such that you can understand the echo mode. Now the comment on the dead band. So the dead band means, in this echo mode, what happens is that if the object is very near to this particular sensor, what happens is that the emitted wave and the received the reflected wave will get interference, and it cannot sense whether the object is there or not. So that is particular called dead band. And you can see in an ultrasonic proximity sensor, there will be the on an on if you're buying that particular ultrasonic proximity sensor, you can understand that on the product it will be mentioned the dead band will be of 1 centimeter, 2 centimeter, etc. So that is the dead band of an ultrasonic proximity sensor. Now the next question is, graphically represent the method to find out non-linearity error. This we have discussed. So the non-linearity error means it is the maximum difference from the straight line. So that is three methods are there. First method is straight line joining the output values at the endpoints. So you have 2 points here, okay, and you are drawing a straight line, but the actual process will be in a curved line. So this one will be the error. So this is the first method. Now in second method, you have an start point and you have an end point here, and you are using the straight line using the method of least squares, but the the straight line which is made using the least square is having some intercept here. It is not passing through the origin, and so this will be the error. Okay. Now the third one, again you are using the least square, but the it is passing through the origin, and this is having the error. So in method 2 and method 3, you are using what the method of least squares, but in the first case there will be an y intercept here. In the second case, it is passing through the origin. Now the next question, explain the main components of a mechatronic measurement system using a block diagram. So this question carries 5 marks, the block diagram carries 3 marks, and the explanation carries 2 marks. The important points you have to mention is the explanation of each component. So you can see a mechanical system is controlled using a mechatronic system. Okay, so you will be having a sensor, there will be signal conditioning element, there will be analog to digital conversion, there will be a computer or software for control for instrumentation, then again digital to analog conversion, then you will be having an actuator. So the in module 1 you are studying about different types of sensors, and in module 2 and module 4 you are studying about different types of actuators like pneumatic, it can be hydraulic, it can be electric actuator, or it can be mechanical actuator. So this is the block diagram. So you have to understand that block diagram is very much for this particular one. Now the next question is, describe the terms non-linearity error, response time, output impedance. This is also the non-linearity error is an repeat question. The question is for 5 marks, and you can see here the non-linearity error carries 2 marks, response time carries 2 marks, and the output impedance carries 1 marks. So this is, so you know the what is non-linearity now. It is the maximum difference from the straight line. Now next one is response time. Response time is the time which elapses after a constant step input which is applied to a transistor to give an output corresponding to some percentage. So it is some percentage, it will, so it may be 90%, etc. So that is which is called the response time. Now the third one is an output impedance. It is connected in series or parallel to the electronic circuit of a sensor whose electrical output signal are interfaced with the above circuits. So this is the three characteristics of a sensor. So the question is getting repeated. Now next question is, explain the principle of eddy current proximity sensor, and the second one is pyroelectric sensor. So the marks for this question is 6 marks. That means eddy current carries 3 marks, pyroelectric carries 3 marks. So the diagram in 3 marks, diagram carries 1 mark, principle is 1 mark, and the working is 1 mark. And in eddy current, the AC is applied to the coil, the magnetic field, a metal which is producing an eddy current. So when sensor coil, you are giving AC supply. When conducting object is coming here, it is distorting the reference coil. Now in pyroelectric sensor, what is happening that due to this particular temperature, this is giving a particular EMF. So that is pyroelectric sensor. Okay. Now explain what is the principle of working of RTD. List out the advantages and disadvantages. The question is for 5 marks. So RTD means there will be changes in the resistance, okay, in a limited temperature range. And the example is platinum, okay. And the advantage is that it is highly stable and give reproducible responses. The response time is 0.5 to 5 seconds. Now the disadvantage, it is less rugged in high vibration, so vibration will affect this measurement, and it is having a high initial cost. So this is an graph we show in that the temperature variation for this particular materials for this particular RTDs, and you can see the platinum is having a straight line, so such that platinum is widely used for as RTD, but it is heavy, costly. And explain the different static and dynamic characteristics of a sensor. The question carries 5 marks. This is an repeat question. You can take any one and you can explain it. Static, any 3 static, any 2 dynamic. If you are having a figure to supplement, it will be an added advantage. Now the next one is I explain the working of rotary potentiometer, acoustic emission sensor. Each carries 2.5 mark. Acoustic emission sensor I have already mentioned. In rotary potentiometer, it is that the resistance element with a sliding contact which can move over the length of an element. So such that you have, if you are moving from this position to here, what happens that with respect to movement, the voltage output will be more. And the equations for this particular is, you can see here, there is an VL voltage here, and you have another RP into 1 minus X here. So you will get RL is parallel with XRP, you will get the voltage VL by Vs using this particular equation. And acoustic emission formula method I have mentioned before, so you have to mention this one. And the application of this particular potentiometer is that in cars it is used in accelerator, pedal position and throttle position, and acoustic emission it is used for the pressure testing of steel manufactured tanks. Now illustrate the working of a differential transformer. This is again a repeat question. You can mention the working of an LVDT here. The question carries 6 marks, diagram 2 marks, principle 2 marks, working and voltage variation 2 marks. Now this is these are the previous year questions from 2015 scheme. The same can be used in 2019 scheme also. So study well, all the best, and the study material of this discussion will be available. I will post the link in the description box. You can have a look at it. Thank you.